Welcome back, Science 10. This is part of the FM3 package, and it is the net force help sheet. And basically, it's just a reading sheet. There aren't any questions to do in this one. There's just basically some explanation and maybe some highlighting of what you can do. So understand the influence of individual forces upon accelerating objects demands familiarity with the various types of forces. Try to understand each of these. And we've used some of these loosely. So the force of gravity or weight, so the force of gravity is the force that the Earth, Moon, or some other massive object exerts on an object, and it is referred to as the weight. So highlight that or underline that. The weight of the object, and of course, usually in our diagrams, it's pulling downwards. Okay, so if we go back to the rocket sled, the weight of the sled, it's what's pulling downwards on you. The normal force is sometimes referred to as the support force, or the force exerted on an object which is in contact with another object. So if we look at the rocket sled here, the ground pushing the sled up, counterbalancing gravity, that is the normal force. Okay. We have other forces. The spring force is exerted by, well, no mystery there, springs that are connected to each other upon its ends. And of course, the size of that spring force depends upon the elasticity of the spring, etc. You won't have to worry about this formula here. We're just looking at concepts here. Sliding friction forces. The friction force is the force exerted by the surface as it moves across it. So back with the rocket sled here, if I'm applying a force, I have friction working against me, and of course this happens in real life. We always have friction when we're sliding things across a table or a sled on snow. It is our reaction there. So it's due to the two surfaces being pushed together. Air resistance is you travel through air, which is pretty hard to not do. It is a force that's working against you. And of course, on this diagram here, I could turn on air resistance. It's like you're wearing a parachute, but you are the parachute. Or in this diagram here, they have the guy wearing a little parachute, so offering air drag, which is kind of like friction. Okay, tension. The tension is the force which is transmitted through a string or rope or wire when pulled tight by forces acting on it. Applied force, that's the force that is exerted on an object due to a person or some other thing. So here, I'm changing my applied forces by moving this toggle bar here. So it's, if I'm pushing the guy, that is the force there. Okay, if we look at the next page, the net force, think of this or write it down, the unbalanced force. So if we add up all the forces and we're left with one that's not balanced, or part of one that's not balanced. By that I mean if we had 60 newtons working against us with friction, 90 newtons applied force, 60 will cancel with 60, leaving me with 30 pulling to the right. So the unbalanced force in this scenario would be 30 newtons to the right, because the up and down ones are balanced. 60 balances with 60, but I have 90 here, so 90 minus that 60 that's balanced leaves me with 30. So think about that. Don't worry so much about this formula. Just kind of understand the concept. And problem-solving strategies here. Sketch the free body diagram, just a block with arrows indicating forces. Label them what they are. And then we're not doing a lot of calculations here, so you won't have to worry too much about that. But then figure out what is there an unbalanced force involved there? And of course this note here says beware, you just simply can't memorize this because each problem will be different. It's better if you can identify these forces here. And I think the next assignment deals with that, indicating is gravity present, is a spring present, etc. Okay? So there you have it. If you're having any difficulty with that, again, go back to this. This is a great little, it's a cheesy Java little animation, but it's really good. It really explains this really well and allows you to play around with this to see how exactly forces work. And especially this is a weird concept for kids to understand. It's already moving at constant velocity. We have an up and down force. How is it still moving? Of course, in real life, we automatically have friction, so we don't see this a lot. But you could balance friction and still have it move at constant speed. Okay? So take a look. Go through these, because the next sheet will involve you looking through these and seeing, are each of these involved or not. Okay? I'll see you again.